Yeah, hello everyone. Today I'm going to show to you a little bit more technical video. So we're going to be seeing code in PyCharm, and we're going to be actually training a model, writing a model from scratch, leveraging PyTorch, classes, dataset and DataLoader, and quite a few from Torch Vision and Transforms and so on. And let me remind you of overall ideas. So as you can see over here, we are ingesting, creating the collection of our database of those image fashion inventory data. And then what's going to happen? So here's kind of the overall chart. So we are going to be dealing with 9 different designers. So every season and every designer, that pair will construct create unique label for the images that we have seen for that specific runway show, and then we are going to train on that data. So in a nutshell, what the model will do at the end of the day during the inference time, the model will actually learn how to, based on the image, predict its designer, and then later on it will learn how to generate an image that is attributed to a specific designer. So in a nutshell, I want to be able to kind of produce new cuts, new trends that are very similar to, let's say, Chanel of season summer 2024, or maybe of Christian Dior of 2019, and so on. So that's what we are going to do. So let's jump very quickly again to our Python code. So we're going to be starting completely from scratch, given the data, and we're going to use the data as a training data. So we're going to start with the data set. When you want to use PyTorch dataset, you just need to implement basically following methods. You need to implement the init method. You also need to kind of show where the data is sitting and load that data. And then you need to specify the size of your data, and you need to implement the get item method. And that's pretty much it. We're also, leveraging the transform, where we're going to resize the images, bring them to kind of a standard way. Here we are loading the data to the designer dataset from PyTorch, and we are basically specifying the data location and that transform that we have set above. Then after the dataset is ready, then we're ready to leverage DataLoader. So that's that. Now let's jump into our classifier. So our classifier is super simple classifier leveraging neural nets. So you will need to implement an init method. In init, you need to specify how many classes we're dealing in this multi-class classifier. So it's over there. We're not starting completely from scratch. We're starting from this pre-trained model that we are getting from the timm library. Timm stands for PyTorch image models. If you want more details, please go over here. There is some code sample and you can read more about that. Let's continue with the code. Then we are basically saying that we are going to be using this very simple neural net classifier that is sequential, and we need to implement another forward step, very simple, getting the features and sending them to the classifier, and that's our forward step. And then 2 more things. We need to implement our loss. Basically, that's our formula how to compute an error and ensure that we can optimize on the error, drive it to 0, hopefully. And that's basically over here. So we're leveraging this adept optimizer, and that's that. So after that is done, we just need to specify a number of epoch, loop through them, update the running clause, and then basically display the results. So we also want to see that our training loss with time, with number of epoch is going to be going to 0. So let me kind of summarize what we have done. So we are leveraging cross entropy loss in our Python code, and there's basically how we compute cross entropy loss. So we are going to compute, well, the library will do it for us, but there is basic 2 steps under cross entropy loss. It's to leverage softmax to basically convert everything to probabilities, and then take a negative log out of it. So in a nutshell, what we're going to do, we're going to penalize wrong probabilities. So that's why the loss is driving to plus infinity when the probability is low for the correct class, and when probability is high for the correct class, your loss is almost 0. Alternative ways to compute loss are over here. I want to bring up this KL divergent loss. It's also very useful. If you want to kind of leverage that, you of course can. It's just another library call. There is also alternative methods to compute optimizers. And what are the optimizers? It's nothing else as basically specifying your learning step, your kind of optimization step to recompute everything, and basically ensure that you're driving your loss down. That's it. Thank you so much for watching.